Hi all, let's take a look at the 3.2 Achieve homework assignment. Uh, this assignment's pretty quick just because we can use the shortcut technique of the power rule on our derivatives. For example, here in this first one, we're taking the derivative of f of x is equal to 1 minus 19x to the negative 1 power. So in order to show you that, let me pull up my work here. Here we go. What I did on that problem is, of course, the derivative of any constant is 0, and then the derivative of the minus 19x to the negative 1, I brought the negative 1 down to the front, multiplied it by 19 or negative 19 to get the positive 19. Then, of course, we have x to the negative 2 power. Now, whenever we write that in terms of positive exponents, the best final answer would be 19 over x squared. And you can see that that's what I entered in here on Achieve. For the second question, it has me looking at f prime of x, where now this one's, the way that they have it written is tricky. F of x is equal to 3x, the group, raised to the negative 1/2 power plus 6. You've got to be careful how you do this one. So please notice how I rewrote this is critical to doing this problem at this point. We don't have a technique called the chain rule, which would enable us to keep this function as it is. Without that, I have to think of this as 3 to the negative 1/2 power times x to the negative 1/2 power. Now, 3 to the negative 1/2 power, that's the same thing as the square root of 3 in the denominator. So you'll see I wrote that as 1 over the square root of 3, and then x to the negative 1/2 power plus my 6. Now that I have it written like this, I can use that power rule and say bring the power down in front, multiply. I'll get negative 1 over 2 on the root of 3, x to the negative 3 over 2. Derivative of any constant is 0. Now when I rewrite this, this x is best in the denominator because of the negative exponent. And then it's inside of a square root to the 3rd power. So I just put that x inside the square root along with the 3, and then it's to the 3rd power inside of there. So our best version of the final answer for this problem would be negative 1 over 2 on the root of 3x cubed. That's a beautiful answer there. I like that one. For the next one here, this one gets shorter. It's just asking us to take the derivative. Now, I need you to understand this notation. This notation simply means take the derivative with respect to t of t to the negative 3rd, and then this is an evaluation bar. Often it's read as such that. So it's take the derivative with respect to t of t to the negative 3rd, evaluate it such that t is equal to 2. So it just means take the derivative, evaluate it at 2. So that's precisely what I did. Derivative with respect to t of t to the negative 3rd is going to be negative 3t to the negative 4th. And then I still kept my bar showing I need to evaluate that at 2. Before I evaluated, I went ahead and simplified and said t to the negative 4th means you have t to the positive 4th in the denominator. Now when I evaluate that, negative 3 over 2 to the 4th power gives me negative 3 over 16. For the next one, it was extremely similar. It just said take the derivative with respect to t of t to the negative 7 over 5 power. So I said, okay, bring the negative 7 over 5 down in front when I take the derivative. Now, soon as you take that derivative, that notation d dt disappears. It's telling you to take the derivative with respect to t, so the instant you do, that d dt must disappear. It's bad notation if it doesn't. So I took the derivative using my power rule, got rid of the d dt. I still need to evaluate it at t equals 1. Before I evaluated, I wanted to write it in proper notations, put the t in the denominator to the positive 12/5. And now I know when I plug in a 1, that's still going to be negative 7 over 5, so I already had my final answer. The next one here, we didn't even have to evaluate it. It just said take the derivative with respect to x of x to the 23 over 6 power. So I said, okay, power rule. Bring the 23 over 6 down in front. It doesn't have anything to multiply other than a 1, so you just get your 23 over 6 in front. And then the power is 23 over 6 minus 1. Well, 23 over 6 minus 6 over 6 gives me the 17 over 6 power. That idea is continued in number 6 here, where you're asked to take the derivative with respect to t of t to the negative pi to the 13th. So a little strange to have that odd of an irrational exponent, but the power rule still applies. So I can say, okay, any exponent number comes down in front and multiplies. So I put negative pi to the 13th times t, and then I subtract 1 from that exponent. So I put negative pi to the 13th minus 1. This would have been a fine final answer. I just wanted to show that the parentheses there was unnecessary, and so I wrote it as negative pi to the 13th t raised to the negative pi to the 13th minus 1 power. And that's, I entered it in Achieve without the parentheses, just like that, and Achieve liked it, no problem at all. For the next question, it's one of these two-part problems, which several of the next parts are like that, where it's going to ask us to evaluate the derivative of a function and then find the equation of a tangent line at a certain point on that function. Okay, so if I do that in this problem, it asks me to find the derivative of 15x to the negative third. Well, negative 3 times 15 gives me negative 45, x to the negative fourth. Rewriting that in proper notation, I can say, well, your derivative is negative 45 over x to the fourth. Now, it asked me to find a tangent line, whether it says x or if it calls it a. Remember, a is just a particular value of x you're interested in. So whether it says x or whether it says at a, in this case, it was at 5. So I can say, well, then I need to evaluate my derivative at 5, and I need to evaluate my original function at 5. My original function at 5 gives me the y value, and I know the coordinate after I do that. So you'll see I plugged in f of 5 into the original function. That gave me 15 over 5 cubed, because it's 15 times 5 to the negative 3. That gave me 15 over 125, which reduced to 3 over 25. So you can see instantly, I know I have the ordered pair. When x is 5, my y value is 325. That's the point. Now the slope is when you plug the 5 into the derivative. 5 is the location we're interested in. Well, we need to know the slope at that point. If you plug a 5 into your derivative equation, you get that. You see I did that here. Negative 45 divided by 5 to the fourth gave me negative 45 over 625. I reduced that down by a factor of 5 to negative 9 over 125. So once I knew my slope and I knew my point, I used the point slope formula. Y minus 3 over 25 is equal to negative 9 over 125 times x minus x1, x minus 5. I distributed through the negative 9 over 25. And when I did that, this 5 canceled out with part of that 125 to leave me just a 25 in the denominator. Then I added 3 over 25 to both sides to get my final answer of negative 9 over 125x plus 12 over 25. Now, like I was saying, there's several problems in this assignment that have us do that same thing that we did in number 7, where we have to evaluate the derivative and then find the equation of a tangent line. So same thing here in number 8, where it said, well, what if f of x is 2 on the cube root of x, and it's wanting us to find both the derivative and the equation of the tangent line at 8. Okay, so before I can find the derivative, I had to go ahead and call my cube root x to the 1/3 power. So my derivative is going to be 2/3 x to the 1/3 minus 1, which gave me 2/3 x to the negative 2/3. I'd prefer you go ahead and rewrite the derivative in proper notation and say, well, that's the same thing as 2 over 3, and then this is going to be the cube root of x to the second in the denominator. So I have 2 over 3 on the cube root of x squared in that denominator. Now I can say, well, all right, I need to evaluate the original function and the derivative at this point. when I plug the 8 into my derivative, you can see I did that here. F prime of 8 is just going to be 2 divided by 3 times, and it's easier if you take the cube root of 8 and square it. And I can say, well, the cube root of 8 is 2, and then 2 squared is 4. I multiply that by 3, and I know my denominator would be 12. Well, 2 over 12 reduces down to 1/6. So now I know, hey, okay, my slope at the point of interest is 1/6. If I need to know the equation of the tangent line, then I'll just say, well, okay, I need to know the y value when x is 8. Plug 8 into your original equation. 2 times the cube root of 8 gives me 2 times 2 is 4. I know that the y value is 4 when x is 8. I have my ordered pair. Now I also have my slope. I plug that into my point slope formula. And I get y minus 4 is equal to m, the 1/6, times x minus 8. And then I can say, well, okay, after I do that, I'll go ahead and distribute through the 1/6 and get 1/6 x, and then I would have minus 8/6, which I've reduced down to minus 4/3. I add 4 to both sides, and I know 4 is the same thing as 12/3, so 12/3 minus 4/3 gave me the 8/3 there. And you can see that in this problem here, that's what they were wanting for the final answer, the equation of that tangent line. Now, actually, the first question here, they didn't technically want f prime of x, they just wanted f prime of 8. But you had to find f prime of x, of course, before you can evaluate the derivative at 8. Now, for number 9, ooh, number 9's cool. It's cool. It's asking us to find the points on the graph of f of x is equal to 81x minus 3x cubed, where the tangent line is horizontal. So you'd say, well, okay, horizontal tangent line, that's going to occur at any point where the slope is 0. So the slope is 0 whenever the derivative is equal to 0. So I just need to take the derivative of this function and find any x value at which it could be 0. No problemo. So you can see that's what I reasoned here. Here's my function f of x. Horizontal tangents are going to be when the derivative is equal to 0. So I take my derivative. Derivative of 81x is 81. Derivative of 3x cubed, that's going to give me 9x to the second. Keep the sign in front of it. So I get 81 minus 9x squared. We need to set that derivative equal to 0 to find out where the tangent line would be horizontal to it. And so you'd say, well, okay, if I set this equal to 0, this left-hand side is easily factorable by difference of 2 squares. I could call it 9 minus 3x and 9 plus 3x. I can find out when each of those factors will yield a product of 0 by setting them both equal to 0. If the first one is equal to 0, then I know 9 minus 3x is equal to 0 is going to give me 9 is equal to a positive 3x, and x is 3. In the second one, if 9 plus 3x is equal to 0, then 9 would equal negative 3x. Divide by negative 3, and you'll get x is negative 3. So the only 2 points at which you're going to have horizontal tangent lines is at x equals 3 and x equals negative 3. Now, Achieve didn't just want the x values, they wanted the coordinates of the points where you would have horizontal tangent lines to this curve. So all I had to do is to find the y values by plugging 3 back into your original function. You see I did 81 times 3 minus 3 times 3 cubed. And you know, since this is an odd function, f of 3 and f of negative 3 are going to be equal and opposite. This function is going to be symmetric with respect to the origin. But I went ahead and showed it out for both of them and showed that f of 3 is going to be the ordered pair 3, 162, and f of negative 3 is going to be the ordered pair negative 3, negative 162. That's a pretty cool problem there. And you can see they just wanted you to list the ordered pairs with a comma in between them there. For the next one here, this one was pretty cool as well. 9, we were finding the points in which we had horizontal tangents, so you had to set the derivative equal to 0. Now we're trying to find when 2 curves are parallel. And if you remember, parallel lines are lines that have the same slope. Well, same idea here. you're going to have parallel curves if their slope at any specific point is the exact same thing, if their rate of changes are the same. So all we have to do is take the derivative of each of these equations and then set those derivatives equal to one another. That's what I did here. So you can see, I said if you have y is equal to x to the fourth and y equals x to the fifth, and we're trying to find when they're parallel. Take the derivative of each using the power rule. I have 4x cubed and 5x to the fourth. Now I can say, well, let's set these two equal to one another. When I do, I'm going to go ahead and set this equation equal to 0. So you can see I subtracted 4x cubed on both sides. Doing that enabled me to factor the right-hand side. I factored out an x cubed, and that left me 5x minus 4. Now, the zero product property tells me these two are equal to one another whenever the first or second factor is equal to 0. Well, the first factor just gives me x equals 0. The second factor gives me 5x minus 4 is 0, which gives me 5x is equal to positive 4, and x equals 4/5. And then you can see on achieve here, I got now they just want you to list the numbers from low to high with a comma in between. So I said 0 and 4/5. Now for the rest of this section, I'll do it in a second video here, picking up at number 11. So please make sure if you need any help with problems 11 through 23 to look at the second part of this video. It'll be posted right after this one.